Good evening, all. Today is our fourth day of this FDP on the horticultural post-harvest technology. And in the last 3 days, we have some of the good and wonderful sessions. Today, at the last moment, we are having some arrangements here because I called phone call to the Honorable Chairman AICT just in the evening around 5 o'clock, and he has kindly accepted our invitation, and he would like to uh, interact with all of you during around 8 to 9, in between 8 to 9, because there is the one meeting with the minister also going on. So as soon as he will free, he will join our program also. So it is a great opportunity for all of us to share the program feedback as well as how the AICTE should do for the agriculture and particularly for the post-harvest technology. So you have to be raise your concerns also with the our honorable chairman of AICTE. And today we have three planned speakers. First one is Dr. Kavya Dashora from IIT Delhi. Other one is the very experienced industrialist, and he is also the IIT alumni, Mr. Vignesh, and from the Vapur, and the third is from the Spain, Professor Maria Serrano. So all these three sessions will be wonderful today. So I introduced you to the first speaker of the day. She already joined here, Dr. Kavya Dashora. So the brief about the Kavya is like that she is the distinguished plant pathologist with specialization in the plant pathology and the tissue culture. Her academic career comprises of her work and contribution at ICAR, then Government, Commonwealth Association, and the United Nations in various capacities, and contributed to teaching, research, development, and innovation. Presently, Professor Dashora is now working as Associate Professor in Nanotechnology and Artificial Intelligence at Indian Institute of Technology, Delhi. Her key areas of research focused on translational research of nanotechnology and artificial intelligence in agri-food sector. She has contributed to more than 12 countries, graduated 4 PhD scholars, and has applied patents for 5 novel products innovated by her. She is also a reviewer and on editorial board of very reputed journals with impact factors ranging from 5 to 15. And she is also an official mentor of STEM program both at IIT Delhi as well as at IIT Abu Dhabi. If you're looking at the work experience, then her career path led her to the United Commonwealth Agricultural System, where she made impactful regional contributions for crop-based management, food security, women empowerment, intergovernmental networking. In this role, she played a pivotal role in agri-food system development, empowering women in agriculture, and spearheading large-scale research programs and missions for global food trade in developing and developed countries. Dr. Dashora is presently working as Associate Professor at Center for Rural Development and Technology and also Associated Faculty at Yardi School of Artificial Intelligence. Her goal is to bridge the gap between Indian farmers and cutting-edge research and technology, utilizing technologies like quantum tech, blockchain, AI, computer vision, and image processing for food safety and security, productivity, and achieving SDG goals. Her innovation in the food technology, including vegan egg and chicken from plant-based proteins, addresses protein malnutrition issues in the country. Dr. Dashora is preparing first ever national digital libraries for crop pests and pathogens and food flavors for restoring traditional Indian flavors using artificial intelligence and deep learning tools. She is also dedication extends to scientific expert committees like DBT, DST, BIREC, Industries, Niti Aayog, Ayush, and Board of Academic Studies in our institute also, and proposal and policy evaluation committees, curriculum design and policy development in India's scientific and industrial sector. Her publication record includes around 80 papers in high impact journals between 5 to 16 and numerous book chapters and technical reports. He is frequently a keynote speaker in various scientific programs. Currently, Dr. Dashora mentors national startups in agri-food system technologies. So his key areas of specialization are nowadays she is working in the translation of the nanotechnology and nanotoxicity and artificial intelligence in plant protection, early disease forecasting, pattern recognition, ecosystem restoration, food security, smart proteins in agri-food systems, valorization of biomass and bioprocess technologies. And she was awarded with so many awards at the national and the international level. So now I invite Dr. Kavya Dashora to present talk on the artificial intelligence in the agri-food supply chain management. So I make you, Dr. Kavya, presenter, and now you can share your presentation.
Whatever I'm going to say, am I audible?
Yeah, now you are.
Yeah, so whatever I'm going to say, I guess I was mute earlier. So, good evening, everyone, and thank you so much, Sunil sir, for this opportunity. And I'm really very happy to be a part of you all today evening. And whatever I'm going to talk today, it is a very interesting thing because this is a science and development. We have yet not completed it. We have yet not said that things are done. Every day is a new achievement. Every day is a new challenge, and every day is a new milestone. So it is as beautiful as seeing a history being made, and when history is being made of science, nothing is more beautiful than that. So I would just share my screen. Okay, are my slides visible? Are my slides visible?
Perfect.
Shall I start, sir?
Yeah, yes.
So the topic for today is AI and ML technologies in post-harvest management and supply chain management of horticultural crops, from data to decisions. Because now whatever we are doing, primarily data is the backbone of everything. So just a brief introduction or just a brief profile. I started my career as a scientist at UNCGIR Commonwealth System, and then I moved up to the ladder to Deputy Director Commonwealth Agriculture. I had 12 years of international R&D exposure and 35 countries in major continents I was posted. And presently I'm working as Associate Professor at IIT Delhi, CRDT, Center for Rural Development and Technology, and also Associate Faculty at Yardi School of Artificial Intelligence. So directly before we come to um, artificial intelligence, let us just speak about what are the four milestones of human history. So the first milestone is cognitive revolution, wherein we had seen the fire for the first time. We started eating roasted food, and our cognitive skills started developing. From there, it was like 70,000 years ago. And we took so much of time before we called ourselves settled or civilized. And it was like around 12,000 years ago, we had agricultural revolution. And after that, you see, it just took 12,000 years. Human being has, because we started eating good food, human being has captured every corner of the earth. They have captured each other. They have tried to develop every possible technology, which is not only helping under earth, above earth, and also in the sky. Now we are even going interplanetary. Then scientific revolution happened 5,000 years ago, and in the scientific revolution helped us with steam engine transportation, exports, growing more crops, producing more fabrics, and more science came into evidence-based science into practice. And then industrial revolution happened 263 years ago. So in respect to agriculture, 263 years ago, first time industry started operating. Then we started having bottled food, packaged food, and we also started to talk about increase of shelf life. So cognitive revolution per se, it just speaks about human intelligence, language, thinking and problem solving, memory, action and perception. So now we speak of industrial revolution or industry 4.0. So the first industry was where we had mechanization started coming in, we had water power and we had steam power. In industrial revolution 2.0, there was a mass production, we had industry assembly line, and also electricity started coming up. Then industrial revolution 3.0, computer automation and robotics, and presently we are at industrial revolution 4.0, which has cyber physical systems, IoT, cloud computing, AI and cognitive computing. Similarly, agriculture also has 4 versions. In agriculture 1.0, we had adoption of modern agriculture. Then, like, we started using tools, we started using plows, we started caring for food and protecting it, conserving it, we started to diversify. Then we came for mechanization. It happened post World War One, wherein tractors came in and harvesters and threshers came in, and industrial revolution 3.0 was green revolution, which we largely benefited, and industrial revolution 4.0, which we are experiencing now, is about the digital revolution, wherein we have sensor based agriculture, we have very carefully selected or graded food, we have longer shelf life, we have cold supply chain, we have real time monitoring. So that is how the industrial revolution, agricultural revolution 4.0 is coming. Now, let's talk a bit about artificial intelligence, because this is the topic for today. So what exactly is artificial intelligence? We are going to study this a little bit in detail, and also since I assume that this is a diverse group of faculty members, so I will just give you a brief introduction, very basic introduction of what is AI MLDL and how they are used in modern agriculture and horticulture, particularly in the supply chains. So when we give machine a task which requires human intelligence, that is known as artificial intelligence. And machine learning is one of the types of artificial intelligence. Others are natural language processing and computer vision. So if you also see the subject transition, it happened from chemistry, the initial revolution happened, then physics when mechanization happened, and then from materials when we started having agriculture revolution 3.0, and presently it is the digital technology, and moreover this era is of biology. When I say biology, I strongly mean agriculture, because agriculture is the foundation of biology, whether it is microbes or whether it is valorization of food waste or whether it is crop, everywhere it is biology, it is agriculture. So I strongly believe that this era is of biology and AI, which is a very beautiful combination. So industrial revolutions, if I just give you another perspective of it, Industrial Revolution 1 was a machine revolution. Industrial Revolution 2 was the electrical revolution. Industrial Revolution 3, when computers started coming in, was a digital revolution. And presently we have biological revolution. Now, when I'm talking about industry, let me give you a small map where exactly we were when we had Industrial Revolution 1.0. We were hungry and dead. Because if you remember the Great Bengal famine, and if you recall the history from your forefathers, they would say that this was a man-made famine because British absolutely stopped our food crops to be grown. Whatever we grew in areas of Bengal, Odisha, and Assam, um, they took all of it to UK for the industrial production, and alone Odisha had faced the death of 1 million people, alone Odisha. So whereas rest of the world, particularly Europe, was thriving in industries based on our resources. So at Industrial Revolution 1.0, we were hungry and dead. When it came Industrial Revolution 2.0, when mechanization had started, Most of our people were workers, they were laborers, because we did not had advanced skills. We were just entering into schools, our colleges were being set up. So we were workers. Industrial Revolution 3.0, we were managers. At computer era, we were able to scale ourselves a bit, and we ended up being manager. And Industrial Revolution 4.0, that is which enables AI, India should be the leader, because India is already a leader in agriculture, and when combined with the AI, we should be the leaders in artificial intelligent agriculture now. So, future of AI, or the fifth industrial revolution, it would be the fusion of robotics, AI, and biotechnology. It would also be creative industries, like the conventional industries would be broken, would be disrupted, and manufacturing would be taken to a new scale, more automized, more precise, and more ethical decisions would be taken. So, as I said in the topic, AI to agriculture, from data to decision, this is a very important aspect, because agriculture is a very data intensive landmass. Agriculture is a very data intensive subject. Everything starting from soil, and under the soil, it is microbes. Everything is in great volumes. We have yet not mapped enough microbes. We have yet not mapped enough varieties in the country or globally. We have yet not mapped type of plants. So if we start doing it, a lot of data generates. And whenever there is data, and data in such a high volume, we call it big data. And if we have to assume a futuristic agriculture, if we have to see that how agriculture, we can minimize the losses, we can make it more productive, and also we can make it more nutritious, customized, then we have to have this data on our table, and we need to know the skills with which we can use this data or process this data. So if you see how data driven decisions are made, leadership, trust, commitment, matrix, data literacy, and training comes in as very important parameters. Data driven decisions are taken, and insights come into the future planning. So, from digital to biological, from digital to agriculture would be our next frontier. And one of the important aspects which I am always discussing nowadays in my talks are the next. The next breakthrough in agriculture would possibly be demineralization. That means we would be taking away all the, dematerialization. We would be taking away all the materials like sensors, like data collectors from the soil, and this data would be collected either by satellites or by the devices which are placed away from the field, because most of them, they end up having a property of emerging contaminants. So I just said that I'm going to give you a very brief background about what is AI, ML, and DL. So, ML is basically, or machine learning is a subfield or subset of artificial intelligence, which give the computers to ability to learn without being explicitly programmed. So, when I say without being explicitly programmed, that means you don't write a program, you just write a small algorithm and immediately shuffles up the data. For example, I'll give you one very basic example. We all have gone through it. When we see the amount, the square foot of land, and then we compare it with the price. So generally, we find that there is a linear trend. As the square feet land increases, the price also increases. But we don't train a data model, or we don't train a machine learning model for this. It immediately does it. It just makes it categorized, and immediately we find that they are clustered, and if we apply a regression model, it is going to give us the boundaries, the best fit, wherein the nearest and the farthest point from the point of regression is clearly understood. Then artificial intelligence is used like machine learning. There are several tools, and all of them are collectively known as artificial intelligence, and which are used to perform complex tasks in a way which are similar to solve human problems. And then deep learning, or DL, also you would commonly hear. And if you have not heard about DL per se, you have surely heard about neural networks. So neural networks are a type of DL where this is also again a type of machine learning only, but they are little more capable, more sophisticated, more autonomous, and they have a processing procedure, like they deal in layers when a lot of data comes to them. So inputs, for example, machine learning state data can start with the type of machine learning data. It can be numbers, that means bank transactions, or moisture, or maybe the weather parameters. It can be pixel images, that means the picture from the crop, the picture from the packeted food, or it can be text, that means the best before date, best before, and then there is a number. So alphanumeric combination, text it can come up, sales report it can come up with. So more the data, better the program. That is why I said a while ago that agriculture is a very data intensive subject. Earlier it was a very resource intensive subject. That means too much of inputs used to go, but now it is a very data intensive subject. So if we see, machine learning per se is of three types, but mostly if you read about machine learning in books, they will give you supervised and unsupervised learning. Reinforcement learning is a very new aspect. It is just like still getting concrete. So I'll introduce that to you. So there are three types: supervised learning, when you have specific labels for data, and you have specific outcome which is desired. You are supervising the training and or learning of the model. Unsupervised is when you are continuously feeding the data, and based on that continuous random data, machine learning learns what exactly it looks like. Now I'll just give you an example. For supervised learning, suppose you want to give you want to develop a model wherein ripe strawberries, so you will keep on giving them ripe strawberries continuously, so that the machine learning models runs it, learns it. And how will it learn it? By the pixels which are generated, RGB, red, green, and blue, and then other pixels. It is just going to make a format, and it is going to say these many pixels, strawberry is ripe. So this is a supervised learning where you have given a machine a proper data set and told him this is the thing you have to monitor. Unsupervised learning is you keep on giving them raw, yellow, stale, brown, red, every type of strawberry, and it keeps on learning it. Okay, if it is brown, it is different from red. If it is yellow, it is different from brown. So it keeps on compartmentalizing it. And when you finally give it, these are the training data set. And when you give a test data set, that means when you finally give one red strawberry, it would immediately say this is a red strawberry, this is ripe. It will first go through brown, yellow, green, and say, okay, this is red, so it is ripe. So you did not supervise it for ripe independently, but the amount of data you fed, it classified itself. So that is unsupervised learning, because you have a hidden pattern which machine learns. And in reinforcement learning, there is a reward every time a data is detected correctly, or every time it is just able to come to a desired conclusion. You have a loop which is closed. That is usually a reward. It doesn't ask a monetary reward. Otherwise it has to go back again to start the process. And the best example for reinforcement learning is like when we say if, then, else. So if it is red, then it is ripe, else it is raw. So if it is detecting this correctly, then the loop closes. If it does not detect correctly, then the loop starts again. And that is very tedious for a computer. Then functions of machine learning is definitely it is descriptive, prescriptive, and predictive. Three major reasons why we use machine learning in agriculture. For descriptive, I just gave you an example. It is ripe, it is raw, it is stale. So it just does a data analysis, and also it recognizes the patterns. So if you see it pre-harvest horticulture crop, let us say chili, for example, or let us say apples, for example, any fruit, any vegetable you may take, when it is in the field, continuous data is being sent. It would start making, there is a pattern. That means the chili is small, then it grows, it is different green in color, the green color intensifies, and once it is absolutely ripe, after so many days, after days of emergence of the fruit, it becomes red, and that means it is absolutely ripe. So this is a pattern which it recognizes. It also recognizes the pattern from multimodal data source. We will talk about multimodal little in a while, but just a brief introduction, like it will say when this is the temperature, when this is the rainfall, this is the disease happening, or this is the ripening index, this is the color of the fruit. So there is a pattern which emerges and it recognizes. So this is descriptive. Now prescriptive is immediately it says, okay, if it has found some specks over it or some diseases over it, then it is going to prescribe you that there is a pest which is coming up. So decision support systems are developed out of prescriptive, and it will tell you, if it is trained on that, that you can spray carbendazim or any other fungicide, copper or silver fungicide for that matter. Predictive, this is mostly used in post harvest mechanisms when we are trying to predict the price. So if this last 10 years 20 years ka data, right now I'm working on India and Israel crops, the common crops, and what is the predictive outcome for the crop prices globally. 10 food security crops we are doing. So and before that we had done for tea. So how much is the aggregation of the tea, and what would be the quality deterioration if the aging of the tea is taken into a parameter? So if 2-month-old tea is there, then there is a specific phenolic compound which develops. So this is a pattern which has developed. Now I can predict that if the tea is kept for 45 days, it will turn, it will get some off smell, or it will not be as strong. So some prediction I'm going to make, and in that it understands the trends. So trend is a word, English word, which immediately comes from the last data, how the things have been moving in a graphical way. You can see that it has gone up, you can see that it has gone down, or you can see that it has gone constant. So either ways, the trend is, whatever be the trend, you would understand that, and you also predict the risk. Now, I told you about deep learning. So neural networks, there are 3 types of neural networks which are commonly used. And in agriculture, neural network is mainly used when we are developing the harvesting or ripening indexes. Now, why developing of ripening indexes is important? Okay, can everybody hear me? I mean, I hope I'm audible. Yeah.
Yeah, continue. You are.
Yeah, okay. Because there was a silence, so I was not sure. Okay. So, why do we really need the harvesting indices? Because India exports a lot of agricultural products to Gulf countries, and the crop value is less. Let us say banana. Banana harvesting does not give them a bountiful of money. It is a limited value crop, but it is a food security crop. And when it is sent to Gulf countries, we don't send it by FedEx. We always send it by ship. So minimum it takes 14 days to go there. Now banana has a property of releasing ethylene. If bananas are harvested ripe, and in, let us say there is a banana cultivation, whole orchard is there, and we harvest a lot of bananas with different ripening stages, we just put it into a container and we transport it. In 14 days, because of ethylene production, the fruits start getting ripe. One group of banana will start producing, then another will get ripe. More and more ethylene, more and more fruit starts ripening up, and banana starts rotting also very fast. So by the time it reaches after 14 days to the Gulf country, the fruit is not even fit for offloading, because it is so ripe, it is almost mushy, it is very very stale now. And you just don't know what to do, because your country has already released it, there is no recipient of that fruit. And when you receive it at the customs at Gulf, at least there should be 7 days, because 2 days they take to clear it up, then 2 days to different parts of that country, and at least 2 days for shelf, and 1 day at least customer will keep with themselves. So at least 14 days it is taking in ship, and another 7 days, so this makes it 21 days ka time. If we are not able to calculate it properly, we waste consignment over consignment. And crops like tomatoes, bananas, they are very very perishable, mangoes. So it is very important to know the layering, at what is the appropriate ripening stage. And how do we do that? We do it by 3 types of neural networks. Recurrent neural network, it is effective for sequence prediction by looping layers through by looping data through layers. That means we are going to study about color, establish a pattern, and then continuously the data is fed and it says, okay, this green color is this intense. After a few days the green and yellow starts emerging, and then it becomes totally yellow. This is recurrent neural network where you are continuously sending the green colored data. Then feed forward is used for tasks like fraud detection with unilateral data flow. When you have, let us say, you want to develop the traceability of liquids, and one of the most notorious and most adulterated liquid of our country is honey. अगर आप FSSAI का डेटा चेक करें और अगर आप वर्ल्ड ट्रेड का डेटा चेक करें तो WTO ने इंडिया के हनी पे बैन लगा दिया था 90s में, बिकॉज वी यूज टू सेंड इन द नेम ऑफ हनी, we used to send a lot of rice molasses and corn molasses, and this is just not accepted because although it is very difficult to detect, दोनों C4 products हैं, दोनों sugar हैं, ultimately it is all C6H12O6, so it becomes very difficult. लिक्विड में लिक्विड का डिटेक्शन वैसे भी बहुत मुश्किल से होता है unless you use radioactive isotopes, and that is a costly technique. So they, like, time and again we were being detected for giving the adulterated honey, so our exports were banned and stopped. So after great difficulty exports were started. So if you want to have a detection system or a food fraud detection system, then feed forward neural networks are used, wherein they just collect the data and keep on checking pretty much the way we do with blockchain, how much the quantity was received, how much it is being processed, what is the color, what is the component. So it is just one way, it doesn't establish a loop. Convolutional neural network, it excels in image recognition. This is, you just give the image of different colors, different fruits, and there is a unique feature. As I told you, green color, specific green color, it becomes important. The size. This convolutional neural network is used for export level grading. When you are exporting, let us say, Alfonso mangoes, so there is a specific length of the mango, there is a specific weight of the mango, there is a specific aroma of the mango, and also the sweetness of the mango. So that, and when they send the export kit, unlike what we get it in the domestic market, different sizes, variable shapes, no, they are very, very symmetrical. And that grading is done by CNN based on the images which is being fed to it. So machine learning helps in a better and more informed decision on planting, on harvesting protocols. I just gave you an example. Risk factors for compromising crop health. It earlier routes the shipments, and also it just tells you that this is the time the bananas are ripe enough, please offload, or this is the time best before is better detected by them. And it also ensures the compliance to global norms of export and food transport. Now, if we say in agricultural monitoring, that means on farm, it gives us the information on weed protection, warehousing, pest protection, intelligent spraying, decision making, weather forecasting, harvesting, soil management, agricultural supply chain, and irrigation. All everything, it is either you can use sensors there, and I strongly support and I believe that multimodals work the best because alone sensor do not do the needful, and they are expensive also. So if we study the supply chain, we have Sunil sir, you would please let me know when I need to close, because I can just go on talking, right?
Yeah,
So
we have sufficient time. Your
we have
session.
sufficient time, sir. Thank you. So when we talk of food supply chain, we have a production, processing, distribution, and retail. So broadly, this is the one, and then somewhere we have packaging also, somewhere we have bottling also, different, but more or less we have covered it all under the processing part. So if every part of it is, if we have AI applied to it, or if we have the machine learning algorithms applied to it, then it becomes very convenient for us to collect the data and keep on monitoring the data. That means more or less making the agricultural value chain very safe. So starting from the on farm production stage, we have crop planning and farm operation. So whether it is soil nutrition or seasonal rainfall or climate forecast, iterative simulations, or it optimal acreage, how much is required per acre of the crop, or per crop how much is an optimum land piece you should be shelling out. Then also it satisfies the demand for forecast and like prediction model. I told you, normally for prediction model we use PCA or predictive analysis or probability starting from general statistics to machine learning. Now AI is also used for sustainable plantation or sustainable cropping, wherein we know that we are not using too much of water, we are not making it resource intensive. Then on matured crops, we had seen it like on farm. Now when the crops are matured, mostly computer vision takes place. This is AI. So mostly computer vision takes place, and it takes place with the help of um, RGB and pixels. So the three basic colors, red, green, and blue. I usually use hyperspectral camera in my lab, but mostly people also prefer taking satellite data or even through drone when they have hyperspectral camera attached to the mounted vehicle or unmanned aerial vehicle. Either ways, the idea is to capture as many pictures as we can. So once the crops are matured, the computer vision integrates. There is a tractor rig, and where we just mount this camera, and it just takes over the entire field. Not only it tells us how much of the crop is ripe, it also feeds in the data for how much yield we should be predicting and then how much income we should be predicting. But at the same time, it is also telling us that how much is the crop under stress, whether it is overripe, whether it is pest or pathogen, or somewhere it is not having enough nutrition. So computer vision just tells us all, it just gives a pre-warning. Now, once we are about to harvest, then intelligent harvesting and yield optimization. So, intelligent harvesting means grading it on the basis of their ripening index. That means we put it into binaries, we put it into numbers. So, when the things are into numbers, it becomes very easy for us to immediately match it. Suppose I go to a field and I say, okay, I see a lot of green papayas, right? And if you see the color transition of a papaya from raw papaya to absolutely ripe papaya, there is dark green to orange. This is the shade which different type maturation stage of papaya shows us. So I would see green, I feel this is very raw. If you would see green, you would say no, this is ripe enough. That means it is very subjective when we look at through our eyes. If we make a number out of it, let us say I say this green is to the value of 1.0, and you see green to the value of when you also look at that green, the number says it is 1.0. No matter by eyes you feel it is ripe enough, but since the number says 1.0, we both will agree that it should be in the field till it reaches 5.0. Okay, so numerics are constants. Eye vision or random color is usually subjective. That varies from one person to another. Similarly, when we talk about, or let us say, freshness, I would say that the flower is fresh or the fruit is fresh enough, and you would say, I think I take a shade lighter than this or maybe a shade darker than this. But if we have a numerical value associated, TSS is 4.4, the color is let us say 5.8. Now this is the perfect ripening stage we want for harvesting. So this is so convenient. Now there is not even a debate, there's no wrong choice. One number absolutely helping us to pick the right stage. Now smart farming actually depends upon three. First, it collects the data from different sensors or different inputs. I told you I'm going to talk about multimodal in a little while. So different input sources, it is going to collect the data and then analyzes it, different AI tools or different machine learning tools. And then finally, the whole purpose of every AI or every machine learning is to create a data decision support system. Otherwise, why would we really use something which is so expensive? Running an AI system is expensive. So, and also it requires too much of data feeding in. It is like very constant system. So why would we do that if we are not able to get a better judgment system or a better decision support system? So ultimate aim in agriculture is to make a decision support system, and that is how this process works. Now, predictive analysis, it makes the prediction after we have harvested for yield volumes, for crop quality, as I said, in grading and in crop variety. So, what variety is more in demand? What variety should we be growing? What variety will sustain low water table? What variety will survive or is susceptible to this? Is resistant to the new pest? So, all that simulation prediction is done by um, the prediction modeling. Now, how they are transforming agriculture, we had been talking about farm based things so far. But if you see, apart from farm based, it is also addressing the data leaks anywhere, starting from farm to fork, wherever the data is missing. That means, suppose we do not know what is our ripening index, we do not know what is the demand, we do not know what is the supply, and in supply chain, definitely demand data matters a lot. Which international sector is asking us for it? What is the immediate requirement? So that data leak is prevented. Then it also helps us about optimization of irrigation. Normally, when we talk about AI and agriculture and horticultural systems, we do not talk about irrigation because we normally take it under engineering systems. But AI and IoT not only tell us how much water would be required for this variety, this crop, this season, and this yield is predicted. They, if we have a sensor to the irrigation channel or a sprinkler, it will immediately detect the soil moisture and say, okay, you don't need to irrigate right now, soil has enough moisture. So we are not making it resource intensive. I told you, we are taking it from resource intensive to data intensive now, optimizing the resources because they are very, very less in number now. They are reducing at a faster pace. Clean water is not enough for us to use it in agriculture. Then also livestock monitoring. Livestock are integral part of agriculture, and normally we do not speak of livestock when we are talking about AI in agriculture. But AI transforms agriculture. They have a small clip here on the ears, and that is continuously measuring the data from interstitial fluid of the animal, very similar to the diabetic sensors which people are using nowadays. They just use their mobile phone and they get the sugar, they don't need to prick their finger anymore. Interstitial fluid continuously keep on giving the data. The inner temperature of the animal is rising, possibly animal is having fever, the animal is in heat, or the milk yield is reducing, or if there is a illness in the animal, everything continuous data is being captured. Like the way we do with a blood test, the interstitial fluids are also a very good source. And those sensors, they provide data, and the health of the animal is continuously monitored. Because dairy, poultry, and piggery are also very important aspects of agriculture, and if we do not know the health of the animal, we end up consuming the milk or the meat from a ill animal, and that is not the idea, that is a bad idea. Then optimizing, how do we optimize it? Every fruit chain, every vegetable chain, and every flower chain, like horticulture would fruit, vegetable, and flowers. So they all would be different. So we just don't have one size fit all. We just can't have what data is good for apple will be good for chrysanthemums, or would be good for um, would be good for chilies. It would be different. So the general layout is, first we have data integration. That means we have either visual data or we have sensing data. Then we have quality control. We control the quality by the data by automated quality assessments and customer satisfaction. Then inventory optimization. If we have sensor based inventories, then the moment it goes, and we have fixed a threshold level, very much those who deal in stocks, there is a term known as stop loss. Below this, it will not go, you will sell it before that. Similarly, below this, the inventory should not go, you will raise an alarm to the store manager. Now, why is it important? Because in horticulture value chain, you also have horticulture processed value chain. That means whenever you add value to the crop, horticulture products are perishable. So if you are adding value, let us say you are making jams or jellies or pickles out of it, so a continuous you have to have a continuous supply of raw material, because the season of the crop would be limited. But The company will continuously provide, but the company will continuously provide uh, pickles in the market. The company will continuously provide jams in the market or sauce in the market. For example, Kisan tomato ketchup. Round the year you get tomato ketchup, but round the year you don't get so many tomatoes cultivated. So inventory management. When the stock comes in, when the processing happens, when the marketing happens, then demand prediction. You would always know when the demand is high if you have a proper demand supply analysis done. Now, to take a little break, I'll just give you a small example. And this is a real story. A few years ago, because Kisan is a brand of Hindustan Unilever, so and they have a buyback contract with with the farmers who grow tomatoes in and around Bangalore. So most of the tomatoes in northern India comes from southern India only. So they had a fixed quantity contract for making the ketchups, and once there was a bumper harvest. So farmers thought that okay, हमारा तो contract है ना, so they just dumped all the tomatoes in the lorry or the carrier van, and they took it outside the manufacturing unit of Unilever, Kisan tomato ketchup. So Unilever said our factory doesn't even have this type of capacity. This is not even the demand. And what do we do? I mean, we can't overproduce, and if we buy everything from you, we don't have that kind of warehousing. So pretty much it is a wastage at our end, so we will not buy that. So they deny how much ever was agreed upon was bought, because the demand of tomato ketchup backward integration had told them that this amount of inventory of tomatoes would be good enough. So based on that, they had bought that much of tomatoes, and extra tomatoes farmer threw on the streets. And if you recall, television had really broadcasted it. All streets were red because they had just thrown, they just don't know what to do with it. It is perishable, they can't send it out now, they are ripened already. So had they knew that there is a process of value addition to it, they would have taken it, made puree out of it, made powder out of it, given to an enzyme making industry, so many other things. Or maybe pickles. In southern India, they also use tomato pickles. So wastage of tomato would have been prevented. They would have already contacted the agencies to come and take the extra harvest. So this is how we optimize value chain, by making a prediction analysis. Now, coming to unimodal and multimodal approaches. What is unimodal approach? Unimodal approach is when we get data from a single source. That means, let us say, sensors. So if we are having data from the sensors alone, then it is unimodal. The good part is it is very focused data. You get very good data, it is very focused, and it is kind of a specialized data. It can be image, it can be text, but since it is specialized, it has limited scope. Multimodal is more in practice, but it is more generic. So you will have images like text, sound, data, everything. It makes the trained model very dense, but then training itself take lots of time, because they have to filter out the noise is when too much of data is coming, and they have to filter out what is the data which they are requiring. That is known as noise. So in general, multimodal system architecture, just for the information, in horticulture we are strongly moving and encouraging multimodal data systems, because farm to customer का बहुत लंबा sector है ये, and different sector places के ऊपर data comes from different aspects. So the overall structure is, one, you have output module, then you have fusion module where the data is processed. When you have input module where data is collected, then you have fusion module where data is processed, and eventually you have output module where a decision support system or a final, whatever you want it to be, that result is delivered. Now, this is just like one example. Unimodal, I will say, write the description of a horse. This I would give it as a prompt, and generative AI, if it is pre-trained, what horse looks like, it is going to tell me a horse is a magnificent animal, so on and so forth. But if I use multimodal, I would say this is the picture, this is the sound of the horse, and the horse looks like this. Then all the instructions are going here, and eventually the results come out, the multiple results come out. This is how multimodal and unimodal works. Common multimodal systems, definitely GPT 4.0. We all know, we all use it extensively. It handles everything. Like 3.5 did not have the capacity to upload text, images, and all. It was images and audio. It was mostly text. But if you see Notebook LM by Microsoft, 50 resources you can put in, even YouTubes, even audio files, even podcast, even pictures, even books, everything. You just load it there and then it just processes it for you. So GPT 4.0 is a very good OpenAI structure. Then Claude works best with text and images. It doesn't work good with audio, and it is very good for visuals like charts, diagrams, photos with impressive accuracy. Gemini, some of them are paid versions also. Gemini by Google, they are working on DeepMind, and Gemini is used for process text, imaging, audio, and video. They are good, I would say they are good, but then I have not found them very precise. They are a little generic. You may have your own experience, but I found Gemini a little generic. Then DALI, we all make fantastic images from DALI, whether it is greeting card or anything. So it is like text to image creation. If you have a text, if you just want to say, okay, draw the diagram of a strawberry farm, it is going to do that. So text to image, it does that. The images are also not very good. So if you see DALI images, sometimes they have 6 hands or something, 6 fingers, or little distorted because it is still getting trained. Then Lava, it is called as Large Language and Visual Assistant Model. This system merges vision and language. It is an open source model. Then Pame is again by Google, and it combines visual and textual data. Then ImageBind, some of them are paid, I told you before also. This is one of the best models which we can create because it has images, text, audio, depth, thermal, and even meteorological data. So too much of information, and it is a powerhouse of, it is a powerhouse of thinking so far, we call it. And then Clip, it connects text with images, and it is known as zero shot learning capability. That means it allows to handle wide variety of image classification without any specific training. Like I give a lot of pictures, it would tell, okay, this is the picture of dog, this is the picture of cat, this is the picture of apples. I have not trained him. I'm just constantly sending him the data, and he's clustering the data in his head or processor. So, as I said, not always and everything is good. There are always risks associated, and this is the history which is being made. So, there are risks associated. First is we are too much dependent on technology. Then, second, definitely there are privacy concerns. We recently heard about DeepSeek, right? And interesting thing, if you had a hearty laugh on that, at least I had it, when OpenAI put a case on DeepSeek saying that they are stealing our data. And everyone was looking at OpenAI, but then you are stealing our data. So many copyright violation cases are there on OpenAI. So they are training the data based on things which are openly available or which are on your Facebooks and whatever. If you just click it, and if you're able to find that data, they're going to train on that data. So there is a stealing war now going on, telling कि आप हमारा data ले रहे हैं, आप हमारा ले रहे हैं, eventually ये सब हमारा data ले रहे हैं. So now I'll just speak a little bit about my own work. So as Sunil sir had mentioned, that we are creating the first digital library of pests and pathogens. So to collect the data, again, agriculture is a very data intensive, we are trying to make it very data intensive source. So we had 28, we collected data from 28 countries and one India. That means 29 states at that time. So it was like so many data points we had. And we let us say like we had 57 data points, and then we trained local farmers how to collect the pictures, how to segregate them, how to write a small caption about the picture, including what is the date of harvesting, what is the variety they are using, what is the location of the crop, so on and so forth, which helps us to sort that data out and make a correlation. So then we started a digital library construction. It was very difficult because sometimes we got structured data, sometimes we got semi structured data. किसी ने सिर्फ फोटो भेज दिया, किसी ने उसको CSV में भेजा, किसी ने उसको email पे ही भेज दिया. So we got semi structured, and sometimes we just even got a voice text saying that my crop is getting yellow, we just don't know what to do. So lot of that data we had to compile and synthesize. So this is just one of the problems I can show you. When we started talking about, we thought that ठीक है हम plant diseases का data ले रहे हैं and then we are going to make a prediction model, digital library out of it. But there were several infections which had similar looks. Like suppose if I say insects, 6 of them were confused with fungus. The initial symptoms were confused with water molds. Some of them were confused with bacteria. 26 got confused with viruses. Because we got picture, we did not get the sample. So there was no way we could biochemically test it and find out कि ये किस pathogen का है या किस pest का है या biotic या abiotic stress है. So we just didn't know. All what we got was a yellow plant. So this is one of the challenges which we get. Now I show you this picture. What do you see in that? What do we see here? We actually see that most of the leaves are there and they all have yellow marks. Some have yellow bands, some have yellow striations, some have yellow specks, but it is a green leaf with yellow marks on this. We exactly got some data like this. Now, looking to it, if a person who has done his studies in plant pathology would say, अरे ये सब बीमार हैं, इन सबको बीमारी लग गई है, रूट प्रॉब्लम हो सकती है, येलोइंग होती है, विल्टिंग होती है. जिसने एबायोटिक फैक्टर्स पढ़े होंगे वो कहेगा अरे ये सब तो न्यूट्रिशन डेफिशिएंसी है. और जिसने दोनों में से कुछ भी नहीं पढ़ा होगा वो शायद ये भी कह देगा अरे पौधा धूप में खड़ा होगा, पानी नहीं मिला होगा, क्योंकि येलोइंग तो pretty much सब में होती है. So when we started classifying, we thought that yellowing is pretty much the first symptom. We had to have AI जो इन येलोइंग के डिफरेंट पिक्सल्स को, डिफरेंट कलर, इन सब कलर्स को बाइनरी में कन्वर्ट करे, इन सब कलर्स को न्यूमेरिक्स में कन्वर्ट करे, and would tell us that this intensity of green and this area under cover of this green speck in this due course of time with temperature this, with relative humidity this, with location this, and with crop this has to be this disease or has to be a zinc deficiency. It is not possible for human to do it, at least not possible for me and my team to do it. So we took the help of AI. Sometimes we got perfectly healthy pictures. We did not know, and a week later, the entire crop was down with the infection. So we applied, like, there is a algorithm we did OTSU. So if you see the two pictures here, the first picture, the top picture is we got, it was like healthy, no problem. It just doesn't appear anything. The moment we face contrasted, the moment we kept everything behind which was visible, and applying OTSU hides, expresses whatever was hidden. So these red specks shows that the spore, there is an additional growth which is going here. So you see, and this was not visible here. This was all green and yellow. So we came to know that the spores have already settled in and they have already started to initiate the infection. Now, as I told you, what did we notice? This is what we noticed, and that is where the confusion starts. It is very difficult to discriminate between macronutrition, macro and micronutrition, nutrition and non-nutritional symptoms. Another examples, like if I just pull out a root, और अगर आप water molds वाला plant देखिए तो वो तो मुरझा ही रहा है. We don't know. अगर मेरी costly crop है, let us say olive है, या let us say gerberas है, या let us say apples हैं, या dragon fruits हैं, तो मैं इस तरीके का crop तो नहीं afford कर पाऊंगी. I have to take immediate measure, but I don't know what problem it is because so many of them, they look so similar. Like these tomatoes, anybody would feel that ये viral infection है या phytoplasmal है, but this is this could be any other thing. This इसको shade में रख दिया होगा, sun में रख दिया होगा. So we just don't know. So right now we are at absolute need of AI for for doing the right detection, for doing the right precision analysis. And what AI will do is AI will assist farmers, decision makers, researchers in a better informed way, and it also initiate the human machine partnerships. Now, as I said, the genetically modified crops or genetic manipulation, India does, by law, we do not allow GM crops for edible crops. We can only allow processed products of GM. This is by law, we are telling. We can have GM soya oil, We can have GM canola oil, but we cannot have canola and soya seeds. We will not have them because GM may affect the biodiversity of our country. The first GM crop which was approved for cultivation was for BT cotton, which is non-edible. And then BT maize, BT brinjal, BT mustard are still under moratorium. They are still under limited trials. We have yet not started commercializing them. But then possibly genetically modified crops, the way world is adopting it, and we don't want to have them, we have to have a screen. And how would you know? AI would tell you that this is a genetically modified crop, or this is a normal crop with a hybrid variety. Then some of the challenges, apart from the images, the language was a huge challenge. Then the type of chemicals, the common names which we were using, there is a huge challenge. Sometimes we call something, they call it something, the commercial name is something, the brand name is something else. We just don't know how to do it. So right now, at intersection of genetics, nanotechnology, and AI, this is the best place to be right now, because we have nanotechnology which is entering for resilient crops, for self-healing crops, for improved soil management by nanocomposting, and we have a prediction device, nanobots, which has AI sensors on it, and they are continuously giving you data. So, agriculture is fast becoming a sustainable, a data driven, a data intensive, and also real time monitored system. There are some challenges also, like not only it works in field, it works on the drone, it works on unmanned vehicles, it works on satellite systems, which is usually difficult for a farmer to buy. So that means more and more cooperative farming, more and more institutional farming would be done, so that the crop losses are reduced, and also the data is collected properly and decision support models are made. Then agriculture in the age of artificial capable intelligence, we have artificial general intelligence and artificial capable intelligence. So AI, when we call of capable intelligence, what addition happens? It it is mood sensitive. It is mood sensitive. That means it can detect the emotion of the plant. They say plants are emotional, and at the same time, emotion of the farmer also. So cognitive cues. So it helps in decision making. Normally, if a farmer is in a bad mood, it would just make a wrong decision, plucking the crop, throwing it away, harvesting. But if we have ACI powered agriculture, it is going to take the information on, is the plant under stress, is the plant relaxed, is the plant having well fed status, well nourished. So there is a happy state for everything. So possibly capable intelligence will take us there. It would let us know what is the present state. Now, what are the new opportunities? We have AI enhanced crop breeding. That means if we want more iron in wheat, or if we want fortified rice to be grown, or if we want purple colored apples, or if we want mango flavored dragon fruit, we will, or karela, mango flavored karelas, we can have it all if it is demand and supply very well mastered. If we know that if this molecule will fit simulated very well, then automation and labor, we would be having more and more opportunities. And then of course data driven farming. Now what are the risks? First risk is centralization of control, because somebody who's having an AI company or AI device would control. Then over reliance on AI. Right now, if you see Chat GPT launch हुए सिर्फ 2 साल हुए हैं, and I have met so many people who say कि अब अगर हमें कुछ भी लिखना होता है, we don't even think, we immediately ask Chat GPT to do it. But human brain is not supposed to do that. Our human brain is developed and designed to think. We have stopped thinking. Emails, mostly all AI written. Recipes in big restaurants, AI responsible. So we have stopped applying our brain, over reliance on AI, that if AI is saying this is ripe, this is ripe, we will not use our judgment. Then open dependence on AI. That means if AI proves it correct, you will get the export license. If not, it is done. So I also strongly feel that after internet, AI is possibly the last and final invention, and now we are making ways for a smarter civilization, because AI right now can do several things which several human beings can do in several days. AI can just do it in minutes. So we are more and more becoming AI dependent. Um, it is true, and you must have heard these stories that in China, one small tiny robot actually moved from its place on its own, convinced couple of other robots, and they all walked out of store. And I'm not making it up. This is true. This is also another story that in Korea, the a robot was made to do overwork. It jumped from the floors. It committed suicide. So that is like our robots thinking. That actually sent a lot of ripples all around the world. That our robots thinking. How did he know he was overworked? I mean, that humans would know, na? Machines are wearing up, program is over. How did he know that he's tired? So, this part is little risky, and that is why we are still working on it, trying to make it more and more safe. I told you these two things because I wanted to present a balanced picture. It doesn't mean that AI will eat up humans. No, it will not. AI is definitely a human controlled technology. I told you, data is provided by humans. It is trained by humans and supervised and unsupervised by humans only. So we definitely stand at the apex of it. Now, the role in shaping the agriculture, we had talked about it, starting from farm, better crop harvesting, better soil health, better yields, then proper marketing, demand and supply management, and better remunerations, all would be done. So AI's impact on specific horticulture supply chain and on farmers, it is cost reduction, increased efficiency, enhanced sustainability, and improved quality. Because if somebody tells me to go to superstore and buy an imported apple, New Zealand ka green apple hai ya Granny Smith state from US hai, I and if God willing, if I can afford that expensive apple, I would go and I would buy. Why? Because they are very good quality apples. They are very good quality harvested apple, produced apple. They would not use pesticides or fungicides or fertilizers in overdoses. They do not have non toxic chemicals, so they are superior in quality. If I am using AI in my own country, I am constantly monitoring and I am making sure that my harvest is of a superior quality. So, horticulture mean this would come out to be a very big help. So, applications starting from precision agriculture to predictive analysis, supply chain optimization, pest and disease management, and automation and robotics. So, I urge let us all prepare for horticulture 4.0 because fruit, vegetable, and flowers, these three are the most traded commodities. And if we are able to produce it better, if we are able to produce it more, and if we are able to reduce the food security wastage here, and valorize them, because the enzymes which are extracted out of fruit peels and all, if AI is applied very well, the demand of the valorized products, we can make a very beautiful, very robust value chain using AI. So with this, with this, I get back to you all. In case there is something which I can answer your queries. I hope I was well on time. I did not overshoot.
Yeah. So thank you so much for the wonderful lecture and the information on the AI and the ML and how we can use it. So all the participants, please post your questions in the chat box.
So one of them says, kindly share your PPT. So that is with Sunil sir, and sir can do that.
Yeah. India has ProTalk AI model.
Thank you. In case, sir, in case if someone is not thinking of any question now, and in case they ask you later, I request you may please pass on the question to me. I can send the answers. Thank you. So I have this question. Can AI be used to detect contamination in grapes? Yes, it can. Any contamination. And what type of contamination are we talking about? Are we talking about too much of pesticides or heavy metal? Heavy metal contamination, it can do it because it is going to study uh, first and foremost, there is a color difference. When pesticide is coated, the real color of the grape and this color differs. Second, the dose which we have applied and the dose which is required. So there is a difference between the two. And then the residues, the AI model, the way we train it, it can give us the contamination level. If we are talking about heavy metal contamination, then the data needs to come in, because AI is basically a program. So the input device, let us say it is a sensor. Let us say it is a sensor. So if sensor is able to tell that the amount of pesticide was more, or the soil was having too much of heavy metal, and if it is a nano sensor, then it would tell it has been imbibed by the plant. This type of data will let us conclude that yes, there is a contamination. But then we need data accordingly, like we need to have corresponding data to make a prediction. And in case of market gulf case study, could you please light on the fermented products? Okay, so what specific fermented products we are talking about for tomatoes? What ferment? Like didn't understand what fermented products we are. We talking about? Let us say fermented soybean or something, or we are talking about pickles or kefir. If you can please explain your question. Then data collection will be time taking process. So that is why I said that horticulture largely we encourage to be a multimodal and a continuous data. If it is from single source only, then it takes a lot of time and we are never sure. So if it is from multimodal sources, then we continuously get data, and initial processes definitely takes time to settle in it. We also takes time to understand what data is interpreting, but very quickly we get onto the job, and very quickly the data becomes continuous. Then it is like not time taking, it is multimodal, say it is continuous, that is not a problem. Then the next one is, what is the challenges in applications of AI in agriculture? So I told you the challenges, like we have over dependence on AI. First and foremost, it is expensive. Expensive to run the system, like we need GPUs, we need big servers. So farming is not that profitable as iron and steel or as cement. So it is difficult for farming to collect so much of amount of monetary value to install these systems. So it is expensive system, no doubt. Then value chain, sometimes it also happens that biasness comes in. Now those who know statistics, they would know a difference between bias and variance. So sometimes overfeeding, overfitting का एक problem हो जाता है, जिसमें the system जो आपका trained model है, it just tries to fit in कि yes, I am the good one, so it just tries to fit in and it gives the wrong results. It is largely happening because we are yet not there wherein we say that this is the perfect system, like GPS, right? GPS, we have algorithm that is now perfect, but initially जीपीएस कितना प्रॉब्लम करता था, हम यहाँ पे होते थे, हमें एटलीस्ट हाफ माइल आगे का वो रास्ता बताता था. Over a period of time, it got trained, it got specialized. Similarly, we are yet not there. So once we reach there, that means the training is very intensive. Then we would be able to say that it is not overfitting, it is giving us the exact values. So challenges are there. We can't completely depend upon AI so far for bigger decision. We have to have man in loop right now, because human intelligence is right now required. But I told you before also that this is, we are in the process of making a history, we are in a process of seeing a system being developed. Maybe 10 years down the line, people will have no work will be a culture, because office work will be done by computers and AI, farming would be done by computers and AI. No working would be a good culture then. But for now, man in the loop is the thing to be. You just can't depend upon it entirely. Then I'm curious to know about your digital library, if you can share. So we are still in process. I mean, so many crops is coming from so many countries, and it is we sometimes we fail miserably to get the picture, to get analysis. Sometimes we are still exploring algorithms, we are still developing it. But I have told you this is the final outcome we are anticipating. So possibly 2 3 years more, it should be there. But pictures are there, so you can just see it. Yeah. So, and next question would be, can it help in shelf life determination? Yes, it can. How it can help? Because let us take an example of cold salad. Cold salads जो super store में मिलते हैं, and if you travel abroad and if you are a vegetarian, this is your common breakfast. You would go to a superstore, pick up a box of cold salad, which is usually kale salad or couscous salad, and you will eat it. But if that salads are mostly made up of raw materials with some seasoning on it. If the raw material, that means your kale or tomatoes or cherry tomatoes, are stale, then you would just eat it raw and you would fall ill. So what happens is, when the packaging is done, there is a sensor which is placed over it. It is either colorimetry sensor or it is the gas sensor, because normally when food rots or the vegetable rots, the color changes. So immediately the colorimetry sensor brings it up that from red it has, because it is trained that way, it has become brown, and the data goes back to the superstore record. It says that this needs to be taken off from the shelf. Now gas sensors, if you have placed it inside the packaging, you would know that as more and more the fruit or the vegetable is rotting, more and more methane is produced, or carbon dioxide is being produced. So you see that sensor starts giving indication. So you know best before it is when that indication is red, amber, and green. If you take three colors, when it is amber, this is the last time you should be using it, and after that, it should be taken off from the shelf. So this is how shelf life prediction is done. And also, I gave you the example of bananas. So in fresh fruits, it is done like, okay, after these many days of harvesting, you cannot consume it because it is bad now, it is rotten. Then thank you. How it is going to help in farmers field? So it is, again, I told you, AI is a program. Input providing devices are in the farmers field, that is sensors, that is satellite data, that is unmanned vehicle. So these are the things which are placed in the farmers field, and they keep on giving the data. So the or maybe the pictures, handheld devices, your flat panel screens, your mobile phones capture these pictures, and then they keep on sending it at the back end, and the farmer keeps on getting the real time update. And yes, we use VOCs. When I say gas sensors, it is volatile compounds which are being released, or maybe the methane gases which are being released. So volatile compounds are also tested for flavor optimizations for tea, for coffee, because कॉफ़ी अगर आप थोड़े टाइम के बाद में फ्रेशली रोस्ट होगी तो उसका एक फ्लेवर अलग होता है, और जैसे अगर आप उसको थोड़े दिन रख देंगे तो उसका वो फ्लेवर सबडी हो जाता है. दैट यू कैन डू. फ्रेश रोस्ट है या नहीं है, फ्रॉड डिटेक्शन, आई टोल्ड यू, they are done with it. Then it is the hot topic. Okay, thank you. The grapes we have done, and thank you so much. Uh, and and thank you so much for your okay, please suggest the best data training software for AI and machine learning for food technology based studies. Now, food technology based study, food technology is a very vast subject. What technology you are talking about? So, are you talking about, let us say, meat packaging technology? Are you talking about dairy technology? Are you talking about pickling technology? Are you talking about, let us say, powdering or pulverizing technology? So, there are too many technologies, and every technology will have coating and shelf life extension technologies. Okay, so what coating we are talking about? There is a data which needs to be fed, and I have told you, if you're taking it by images, I gave you the whole list. In fact, the models I gave, all of them, most of them are free, some of them are paid. You can start using it. I strongly recommend that you start, those who are interested may start learning Python, because it is a very basic thing. देन स्टैटिस्टिक्स, पाइथन भी नहीं सीख रहे हैं, एटलीस्ट स्टैटिस्टिक्स अगर आप सीख लें. स्टैट्स में भी मैं आपको दो तीन चीज़ें बता देती हूँ. लीनियर रिग्रेशन सीख लीजिए, लीनियर अलजेब्रा सीख लीजिए, देन प्रोबेबिलिटी सीख लीजिए. सिर्फ ये तीन चीज़ें अगर आप सीख लेंगे, मोस्ट ऑफ द मशीन लर्निंग इज कवर्ड. फिर अगर आप कंप्यूटर विजन करना चाहते हैं तो आरजीबी एनालिसिस, उसके लिए लाइक आप कौन सा कैमरा लेते हैं, हाइपरस्पेक्ट्रल या इमेज कैमरा, उसका अपना सॉफ्टवेयर इज ट्रेन्ड फॉर इट, सो आपको उसको अलग से करने की जरूरत नहीं है. सो एंड देन प्रिडिक्शन मॉडलिंग के लिए प्रिडिक्टिव एनालिसिस इज बेस्ट. शेल्फ लाइफ प्रिडिक्शन इज और एक्सटेंशन, इनके लिए भी हम प्रिडिक्शन एनालिसिस करते हैं या हम गैस सेंसिंग टेक्नोलॉजीज यूज करते हैं. सो दीज आर लाइक दीज आर वेरी बेसिक. अगर आप सिर्फ ये 3 चीजें कर लेंगे, आपको मोस्ट ऑफ द मशीन लर्निंग आ जाएगी. उसके बाद में अगर आप डीप लर्निंग करना चाहते हैं, दैट मीन्स वेरी स्पेसिफिक, देन यू शुड लर्न न्यूरल नेटवर्क्स. उसमें भी आप CNN कर लीजिए, काफ़ी है. फास्ट फॉरवर्ड या फीड फॉरवर्ड के लिए, अनलेस यू आर अ पार्ट ऑफ एक्सपोर्ट वैल्यू चेन, यू एक्चुअली डोंट नीड टू डू इट. अगर आप सिर्फ न्यूरल नेटवर्क्स का मैकेनिज्म समझ लेंगे, लेयर ऑन लेयर, हाउ डज इट हैपन, तो भी इट इज गुड इनफ. एंड वंस यू स्टार्ट डूइंग इट, देन देर आर, इट इज अ वेरी इमर्जिंग फील्ड. आई मीन आज मैं आपसे बात कर रही हूँ, हो सकता है नेक्स्ट टाइम जब हम मिलें तो 10 और सॉफ्टवेयर आ चुके हों या 10 और टेक्नोलॉजीज आ चुकी हों. सो राइट नाउ वॉट एवर वी हैव, आई हैव ऑलरेडी टोल्ड. Then okay, what would be the way to reduce the challenge like data induced bias? Now this is a very good question. Data induced bias will always happen because we are dealing with a very versatile type of our subject. हमारा input source बहुत versatile है. जैसे अगर हम मार्केट में चले जाएं, पोटैटोज के हमें 20 तरीके के ऑप्शंस मिलते हैं, छोटा बड़ा, थोड़ा क्रुकेट, तो बिल्कुल स्मूथ. सो वैरायटी ऑफ पोटैटोज वी गेट. Now, if you want to say export quality, you give them the parameter, and then आप कैसे डिटेक्ट करते हो किसी सिस्टम में मैक्सिमम बायसेस हैं? बायसेस इज व्हेन अगर वो किसी एक पैरामीटर को ज्यादा प्रेफर करता है, तो आपकी ट्रेनिंग, यू हैव टू स्टिच इट बैक. आपकी ट्रेनिंग क्या है? अगर आपकी ट्रेनिंग उसके आपने राउंड परफेक्ट पोटैटोज पे उसको ट्रेन किया है, तो उसकी बायसनेस उस पे होगी. सो टू रिमूव द बायसनेस और टू रिड्यूस द बायसनेस, रिमूव कभी नहीं होती क्योंकि हम एग्रीकल्चर से डील कर रहे हैं. टू रिड्यूस द बायसनेस, more and more data, versatile data, different type, different color, different growth stages. मतलब आप जितना डेटा ट्रेन करेंगे उतना ही बायसनेस रिड्यूस होगा, बिकॉज नाउ इट विल हैव मोर डेटा पॉइंट्स टू कोलेट. I guess that is all. Can you suggest a good hyperspectral camera for field? So Specim ka hyperspectral camera, I'm not promoting this brand, but this is what I use. There could be better. I mean, मेरा बजट मुझे स्पेसिम के लिए अलाउ कर रहा था, तो मैंने स्पेसिम ही लिया था. बट आप पूछ लीजिए, इंटरनेट पे होगा. आप एक्सपोर्ट लाइक एट IIT हमें तो जेम से ही लेना होता है. सो फिर मेरे पास लिमिटेशंस भी थी कि जेम से लेना है, मेरा बजट भी कम है, तो फिर मैं स्पेसिम का ही लूंगी. बट अदरवाइज आप और भी एक्सप्लोर कर सकते हैं. पर से हाइपरस्पेक्ट्रल कैमरा फॉर एग्रीकल्चरल पर्पसेस आपको काफ़ी ऑप्शंस मिल जाएंगे. Neural network is difficult to understand. Can you explain it in simple words? Okay, so I'll try. Okay, मैं सिर्फ कोशिश करती हूँ. I really wish आपको समझ में आ जाए. So neural network क्या है? जैसे एक information मेरे पास आती है, या let me give you a better example. हम सब निफ्टन के यहाँ पे इस बॉक्स इनबॉक्स के ऊपर हम बैठे हुए हैं, वेबएक्स के इनबॉक्स के ऊपर. अब मुझे सुनील सर ने कहा था कि आपको एक टॉक देनी है इसके ऊपर. सो आई अग्रीड. सो मेरा टॉपिक था कि इमर्जिंग टेक्नोलॉजीज, पोस्ट हार्वेस्ट मैनेजमेंट, AI एंड ML. सो माय ब्रेन सबसे पहले इसने क्या, किस तरीके से इंफॉर्मेशन प्रोसेस करी. सबसे पहले इसने सुनील सर का मैसेज कि दिस इज द इवेंट फैकल्टी ट्रेनिंग प्रोग्राम, आपको टॉक देनी है. सो माय ब्रेन टुक टॉक. अब इसके पहले की सारी टॉक्स के बीच में इट मेड मी वंडर कि मैंने वो टॉक वहां दी थी, वो टॉक वहां दी थी, वो टॉक वहां दी थी, क्या मेरे पास, इज इट द सेम ग्रुप ऑफ पीपल और इज इट अ डिफरेंट ग्रुप ऑफ पीपल. इसमें व्हाट इज न्यू, इस टॉपिक में व्हाट इज न्यू विच आई हैव नॉट प्रेजेंटेड बिफोर. इसमें दिस इज हाउ आई एम लिंकिंग वन विथ अनदर. इसी तरीके से जब आपसे कोई बात कहते हैं कि अगर मैं कह दूं दिल्ली में इलेक्शंस हुए हैं, सो इलेक्शन वर्ड इमीडिएटली आपको कहाँ से कहाँ लेके जाता है? आपको लेके जाता है 3-4 पॉलिटिकल पार्टीज, आपको लेके जाता है उनके मैनिफेस्टो पे, आपको लेके जाता है आपके 5 साल आप उनके साथ लॉक कर लेंगे, सो यू हैव टू सी कि द सूटेबल कैंडिडेट शुड विन. आपको ये भी देखना है कि अच्छा इलेक्शन है मतलब उस दिन छुट्टी है, there are several nodes which get activated. वो सारे के सारे नोड किसी कॉमन थ्रेड से कनेक्टेड होते हैं. इस केस में जो मैंने बताया इलेक्शन, पहले वाले केस में टॉक एट निफ्टम. इसी तरीके से जब मैं कहती हूँ हार्वेस्ट या राइप फ्रूट्स मुझे हार्वेस्ट करना है, तो राइप फ्रूट से रिलेटेड जितना भी डेटा होगा, दैट मीन्स वो वेदर क्या है उस जगह का, पैरामीटर क्या, वेदर पीएच क्या है सॉइल का, वैरायटी क्या है क्रॉप की, फिर उसके डेज आफ्टर सोइंग कितने हो गए हैं, कलर क्या हो गया है, सावरनेस कितनी है, ये सारे के सारे डेटा मेरा माइंड या जो कंप्यूटर सिस्टम है, एग्जैक्टली लाइक ब्रेन, न्यूरॉन्स हमारे ब्रेन में ही तो होते हैं. सो उसी बेसिस के ऊपर हमने न्यूरल नेटवर्क्स भी बनाए हैं. सो वन आफ्टर अनदर ये एक दूसरे को कनेक्ट करते हैं. अनलाइक लीनियर मॉडल्स जहाँ पे वो वन एक के बाद एक, जैसे आम है, हरा है, येलो हो गया, पका है, ये स्ट्रेट मॉडल है. अब अगर मैं कह दूं हरा है, लेकिन लंगड़ा तो हरा भी अच्छा होता है, सो हरा है, उसका टीएसएस टोटल सॉल्युबल शुगर लेवल क्या है. अगर ये नॉर्थ ईस्ट इंडिया से आ रहा है तो फिर लंगड़ा नहीं हो सकता, तो फिर उसकी वैरायटी क्या है. जब मैं कई चीजें एक साथ प्रोसेस कर रही हूँ, तो फिर वो डिफरेंट सेगमेंट्स उस एक आर्म पे जाके कनेक्ट हो रहे हैं. एंड दैट इज व्हाट इज वी टेक न्यूरल नेटवर्क्स. व्हेन आई ट्रेन इट ऑन अ मल्टी मॉडल डेटा, एक्चुअली न्यूरल नेटवर्क ही वो मॉडल होता है, क्योंकि मैं कई जगहों का सोर्स डेटा फ्रॉम डिफरेंट सोर्सेज आई फीड टू अ कॉमन पॉइंट, और उन सबको फिर एक्सट्रैक्ट करके मैं एक कॉमन डिसीजन लेके आती हूँ कि येस दिस मैंगो इज फिट फॉर एक्सपोर्ट, और येस दिस मैंगो इज राइप इनफ टू बी ईटन, और इट इज रॉ, जो भी. Did I do justice, Miss Nidhi Segan? Did I? No, sorry, Mr. Dilip Kumar, Dr. Dilip. Did I explain it? Was it simple enough? Then how does AI integrate with IoT and sensor technology in cold storage? Good, I'm happy you were able to understand. In case you still need more discussion, you may actually ask Sunil sir, I'll do that. So AI integrates with IoT and sensor technologies. AI is मेरे पास जितना भी डेटा आएगा उसको प्रोसेस करना है, ठीक है. सेंसिंग टेक्नोलॉजी और इनपुट प्रोवाइडर्स, उस इनपुट से देर आर टू वेज. इन जितना भी सेंसिंग होगा वो सब के सब एक रीड आउट नाम के डिवाइस के ऊपर आता है. अब या तो मैं उसको देखूं और सोचूं कि ये कहना क्या चाह रहा है. जैसे हम कभी भी एनएमआर करें या हम कभी भी एफटीआईआर करें, हमें ग्राफ दिखाई देता है और हम सोचते हैं ग्राफ क्या कह रहा है. अगर मुझे पता नहीं है इनपुट सैंपल क्या है, सो आई माइट थिंक व्हाट इज दिस ग्राफ टेलिंग मी, राइट. It is just some lines here and there. What exactly it is telling me, I don't know. That is what exactly readout does. When it collects the data from the sensors or from any IoT device, it just puts the data in a form which I don't know. So what I do is I convert it into the machine language, which machine language tells me in my natural language, which I understand, that is English or Hindi. Bhashini does it in Hindi, but mostly it is English. So jab, again I'm going to walk you through. मैंने एक एप्पल लिया, एप्पल का कल्टीवेशन या मैंने उसकी राइपनिंग इंडेक्स सेंसिंग से देखी. अब कलर इमेज मैंने ली, सेंसिंग से मैंने पिक्चर्स इमेज सेंसिंग मैंने लगाई. अब वो सारी की सारी इमेजेस कंप्यूटर में या मेरे एआई या एमएल प्रोग्राम में इन टर्म्स ऑफ डेटा, दैट मीन 0101 ऐसे करके जाती है, बाइनरीज में जाती है, सो या फिर पिक्सल्स में जाती है. यू नो, इट जस्ट पुट्स द थिंग्स हियर एंड देयर. अब मुझे थोड़ा ना पता है कि उसके बैकग्राउंड में क्या चल रहा है. सो आई वुड लाइक टू नो, इज दिस एप्पल राइप इनफ टू ईट. सो अब वो जो मशीन लर्निंग है वो नेचुरल लैंग्वेज में कन्वर्ट होती है या लार्ज लैंग्वेज मॉडल्स में कन्वर्ट होती है, और वो मुझे कहता है, मुझे तो स्क्रीन पे क्या दिखाई देता है, येस दिस एप्पल इज राइप इनफ टू ईट, या इट विल टेक 2 more days टू बिकम राइप इनफ टू ईट, राइट. सो दैट इज हाउ, अगर मैं कोल्ड स्टोरेज कर रही हूँ मिल्क पर्टिकुलरली, the microbial load is this much, the sourness index of the milk is this, the temperature is this, the distance by the chilling van is this, so the milk will remain safe for consumption for so many days. Is it clear? Is it clear? Was I able to explain? Now, are there any questions left? In case there are any, please you may ask Sunil sir, and we will try our level best to answer you.
How does AI integrate with IoT and sensor technologies in cold storage and transportation?
सर ये मैंने अभी बताया कि कोल्ड स्टोरेज में टेम्परेचर वो लेगा सेंसिंग से, कि जैसे मिल्क का मैंने एग्जांपल दिया, मिल्क के जब चिलिंग वैन्स चलते हैं या कोल्ड ट्रांसपोर्टेशन होता है इनका, तो उसमें इट इज़ वेरी इंपॉर्टेंट टू मेंटेन अ पर्टिकुलर टेम्परेचर, नहीं तो वो दूध फट जाता है, उसमें माइक्रोबियल ग्रोथ स्टार्ट होती है, एंड दैट मिल्क ऑल्सो ट्रेवल्स इन डिफरेंट पार्ट ऑफ द कंट्री। सो एक तो चलती हुई गाड़ी हमेशा गर्म होती है, दूसरा जब वो वार्म टेम्परेचर्स में जाता है तो ऑब्वियसली हाउ मच मोर टेम्परेचर नीड्स टू बी adjusted or modulated. This sensing does it. Sensors will tell that okay fine, the internal temperature is this, it is maintained this, or it is rising, so you need to stop the car, adjust it still lower, and then it comes to you on the screen that this action needs to be taken. और IoT is like suppose हम फील्ड में हैं और हमें वेजिटेबल्स, आई गेव यू दिस एग्जांपल कि अगर हमें यहाँ से गल्फ कंट्रीज में बेचना है एंड इट टेक्स 14 days, and it takes 14 days to ship the consignment, I should absolutely know what is the ripening stage right now. And then this is the harvesting, H we call it. So consumer portal पे जब ये जाता है, so we call it C. So C -21 पे मेरी हार्वेस्टिंग होनी चाहिए, दैट मीन्स कंज्यूमर टेबल पे जाए उसके 21 दिन पहले मेरी हार्वेस्टिंग होनी चाहिए, सो दैट 14 डेज में ट्रांसपोर्ट के रख रही हूँ, फिर उसके बाद 2 डेज में कस्टम सर्विस के रख रही हूँ, 2 डेज में सुपर स्टोर के रख रही हूँ, एंड देन 2 डेज आई एम कीपिंग फॉर कंज्यूमर टू कीप इट इन द फ्रिज। सो वो स्टेज कौन सी है, दैट मीन्स उस टाइम में स्किन का कलर क्या है, उस टाइम में टोटल सॉल्युबल शुगर्स क्या है, उस टाइम में वेदर क्या है, उस टाइम में टोटल इथाइलिन कंटेंट क्या है, जो भी हम फ्रूट राइपनिंग के लिए देखते हैं वो सारा का सारा I get as a collective information, and then it helps me to take a decision, because eventual goal is to make a decision support model.
Okay, I think there is no more questions, and time is also 7:36. So our next speaker has already joined. Otherwise,
Right. So I'm sorry we shot a little overboard, but thank you so much for the opportunity.
But you can answer the last question about the deep sea. Nowadays, we are hearing this word.
Yes. So what is the question actually?
So why you worried with the deep sea kitchen?
Why am I worried with the DeepSeek? Yeah, I'm worried with any AI model which gets trained from internet sources, because internet pe we have right and wrong information both available freely. So if the model is being trained and it is not verified, then you do not know what eventual outcome it will tell. और लोग तो गूगल पे भी अपना पूरा डॉक्टर प्रेस्क्रिप्शन ले लेते थे, तो डीप सीक से तो वो अपना पूरा साइकोलॉजिकल काउंसलिंग तक ले लेते हैं, या चैट जीपीटी से अपनी पूरी साइकोलॉजिकल काउंसलिंग लेते हैं. नाउ इमेजिन अ टूल विच इज कॉन्स्टेंटली फेड ऑन हाफ राइट एंड हाफ रॉन्ग. इट डज नॉट हैव द जजमेंटल कैपेसिटी कि नहीं नहीं ऐसा नहीं है, ये रॉन्ग है, दिस इज द. अब किसी को थ्रोट पेन है और वो कह रहा है कि आप जाके सर्जरी करा लीजिए या कुछ और ट्रीटमेंट ले लीजिए, बट द राइट ट्रीटमेंट इज यू शुड गार्गल. सो इस पे अगर इंफॉर्मेशन कम है या नए कैंसर ट्रीटमेंट पे इंफॉर्मेशन कम है और वो कोई पुराना ट्रीटमेंट एज अ सोल्यूशन दे देगा, सो पीपल विल टेक इट ऑन द फेस वैल्यू. सिमिलरली इन एग्रीकल्चर अगर एक बैंड केमिकल है और वो अपडेटेड नहीं है इंटरनेट पे, किसी ने अभी उस पर पेपर नहीं लिखा है या कोई रिपोर्ट नहीं छपी है, फार्मर को वो इन्फॉर्मेशन आ जाती है, हाँ आप ये वाला केमिकल यूज कर सकते हैं, फार्मर ने वो केमिकल यूज कर लिया टू स्प्रे, हिज क्रॉप विल बी बैंड फ्रॉम एक्सपोर्ट, उसको तो लॉस हो जाएगा. सो मुझे ऐसा लगता है कि ओपन एआई शुड बी यूज्ड विथ रेगुलेशंस, बिकॉज टू फीड इन और टू ट्रेन द डेटा we don't have any control of what people are posting in. मैं आपको एक रियल एग्जांपल बताती हूँ, एंड इट इज रियली रियली हिलेरियस. हम एक डॉग का पिक्चर ट्रेन कर रहे थे कंटिन्यूसली, हम बहुत क्लोज पिक्चर हम ट्रेन कर रहे थे, दैट मीन्स आईज एंड जस्ट नोज पार्ट ऑफ इट. हमने करीब 300 फोटोज डॉग के ट्रेन किए, एंड जस्ट फॉर फन हमने एक चॉकलेट चिप कुकी उसको एज अ ट्रेनिंग डेटा सेट दिया, उसने उसे भी डॉग डिटेक्ट कर लिया. सो दिस वाज रॉन्ग. आई मीन ये ठीक है, हम वी न्यू वी आर ट्रेनिंग इट ऑन चॉकलेट चिप कुकी, और अब तक हम डॉग पे ट्रेन कर रहे हैं. बट आप इमेजिन कीजिए ऐसा कोई प्रिस्क्रिप्टिव अगर उसने सोल्यूशन दे दिया तो इट कैन कॉस्ट पीपल समथिंग। इसलिए मुझे लगता है थोड़े से रेगुलेशन के साथ में यूज हो या फिर थोड़ी मेच्योरिटी के साथ में यूज होना चाहिए। इट शुड नॉट बी कि अब आ गया है तो सब कुछ एआई से ही हो। मैन इन द लूप अभी वी हैव येट नॉट डन अवे विद द सिचुएशन। डीप सीक का थोड़ा सा कंसर्न दूसरी कंट्रीज को ये है कि चाइनीज का तो कोई भी प्रोडक्ट होता है तो उन्हें लगता है कि इट इज फॉर स्पाइंग। थोड़ा सा इसमें पॉलिटिकल वॉर ये एआई ने ओपन एआई ने मिलियंस एंड बिलियंस ऑफ डॉलर से जो चीज़ बनाई चाइनीज ने उसको सिर्फ 10 मिलियंस में बना दी एंड इट इज़ द मोस्ट डाउनलोडेड ऐप इन यूएस। सो देर इज अ कमर्शियल वॉर मोर विच इज गोइंग